Hello everyone. I'd like to do an example of using a power reducing identity to rewrite an expression. So in this example, I'm given the cosine to the fourth power of x, and I want to rewrite that in terms where we don't have any term in there that has a power greater than 1. As we move forward, and as you make your way into calculus, being able to rewrite expressions, in something that's a lesser degree can prove to be very useful. So we want to take the cosine to the fourth of x, and I want to rewrite that in terms that's something no greater than 1. Okay, so our power reducing identities, they all work with something squared. So cosine squared of theta is what our identity is for. But the cosine to the fourth, I can rewrite this as something squared. So I can rewrite this as the cosine squared squared. Okay? The other way you could think about it is you could split this up. This is 4 cosines multiplied together. So you could write this as cosine squared of x times another cosine squared of x. It's the same idea. So, but now that we have it written like this, inside our parentheses here, I have an identity for that, so I can substitute that out. So our identity, the cosine squared of x, that is the same as 1 plus the cosine of 2x over 2. And this is still squared. Okay. So not done yet, because this is still raised to the second power. So I don't want any power greater than 1, so I need to keep working with this. So let's square our fraction. To square the fraction, we are going to square the numerator. So this is all going to get squared, and we'll square the denominator as well. In the numerator, this is a binomial squared, so we can use our pattern for that. So 1 squared. In the middle would be cosine 2x plus another cosine of 2x. So that's 2 cosine 2x. And then lastly, this is going to be the cosine of 2x times itself. So the cosine squared of 2x. And that is all over 2 squared, which is 4. All right, got to keep going. I still have a cosine squared here. I don't want a power bigger than 1, so we're going to have to replace that out. But it is a cosine squared of something, so we can use our identity here as well. So copy down the beginning, and then replacing the cosine squared, we're going to use the same identity, but now instead of just x like we did up here, we just have to make sure that we put in 2x. So 1 plus the cosine, and then in this case it's going to be 2 times 2x, and that is all over 2. This whole thing is still over 4. Alright, so it's kind of messy so far, but we can work with this a little bit. Alright, so we got 1 plus 2 cosine of 2x, and then we have this fraction. I'm just going to multiply those things together. 1 plus the cosine of 4x over 2. This is all over 4. Now, to try and simplify this and make it look a little bit nicer, I'm going to split all of these up. So just each one's going to be its own fraction with a common denominator. So we have 1 over 4, and then 2 cosine of 2x over 4, and then 1 plus cosine of 4x, and then this is over 2 over 4, so that's the same as over 8. All right. Now let's finish this up by getting a common denominator, and then we can rewrite this a little bit. So we do have options. I'm just going to approach it this way. I could factor out something as well, but multiplying top and bottom here by 2. Same thing with this one. And now we can add all of this together. So we have 2 and then plus 1, so that's 3. And now these are not like terms because 1 is the cosine of 2x and this is the cosine of 4x, so plus 4 cosine of 2x plus cosine of 4x. That's all over 8. So there we go. So that now has no power greater than 1, and that's an equivalent expression.